You're standing at the counter in your local tackle shop, two base rods in your hands. On the left is a sleek, brightly colored rod asking for $80. On the right, a subdued, almost boring-looking stick demanding over $200. The price tag on one of them makes absolutely no sense when you look under the microscope, but the guy behind the counter is telling you the expensive one is just built better. Here is what stops most people cold. The global fishing rod market is worth over $1 billion annually, and a massive chunk of that revenue is generated by selling you cheap fiberglass filler disguised as aerospace-grade graphite. The industry deliberately hides the actual carbon tonnage and resin ratios behind flashy trademarked names, so you can't compare apples to apples. They don't want you to know that the $80 rod and the $200 rod might literally be rolling off the exact same mandrel in the exact same overseas facility. We are going to break down 10 of the biggest rod brands on the market, counting down from 10 to 1, to show you exactly what that price difference actually buys you in terms of sheer material science. And if you're the kind of angler who hates wasting money on marketing hype, you might want to stick around because the math is about to get very uncomfortable. Starting off at number 10, we have Favorite Fishing. This is a brand that has absolutely dominated social media feeds, heavily pushed by influencers, and flashy marketing campaigns. But let's run the math the industry doesn't want you doing. When you strip away the bright red and blue paint jobs and look at the actual cross-section of their entry to mid-level blanks, you are looking at standard 24-ton carbon. Tonnage refers to the tensile modulus of the carbon fibers. 24-ton is the baseline entry-level standard for modern graphite rods. It is relatively heavy, requires a significant amount of resin to bind the fibers together, and lacks the crisp sensitivity needed for bottom contact techniques. Yet they are selling these rods at a premium price point based purely on cosmetic appeal and influencer endorsements. The engineering reality is that you are paying for the paint, not the performance. You are getting a heavy resin-rich blank that dulls vibration transfer from the bait to your hand. Tell me down in the comments, what is the main technique you throw? Are you a bottom bouncer throwing jigs and Texas rigs, or are you moving baits all day? Because if you need sensitivity, high-resin 24-ton carbon is your worst enemy. Moving to number 9, we look at Lew's. Now Lew's makes some incredibly reliable reels, but their rod division tells a very familiar story of industry consolidation. When you examine the material composition of their popular sub-$100 rods, you see the pervasive use of IM6 and IM7 graphite designations. Here's the fact that trips anglers into discarding perfectly good gear. The IM rating system is essentially an unregulated marketing term in today's market. Originally developed by Hexel Corporation decades ago, IM6 meant something specific in terms of millions of pounds of modulus. Today, factories in Asia slap IM6 on any standard modulus graphite. When you measure the wall thickness and the scrim layer, the fiberglass mesh used to give the carbon tube crush strength, you find that many of these rods are carrying excess weight in the lower third of the blank to compensate for cheaper, lower modulus carbon. The balance point is shifted forward, causing tip heaviness that fatigues your wrist after 8 hours on the water. And it gets better. At number 8, KastKing enters the fray. They built an empire on direct-to-consumer value, but when you look at the engineering of their rod lineups, especially the models hovering around that $50 to $70 mark, the material science reveals a heavy reliance on composite blends. A composite rod mixes carbon fiber with linear fiberglass. While this makes the rod incredibly durable and difficult to snap on a boat flip, it completely kills the transmission of high-frequency vibrations. KastKing will market these with aggressive names, highlighting their indestructible nature, but from an engineering standpoint, achieving durability by simply adding more fiberglass and epoxy resin is the cheapest, oldest trick in rod manufacturing. You aren't getting advanced nanoresin technology or high-pressure rolling. You are just getting a thicker, heavier tube. The money you save up front is paid back in lost sensitivity and missed strikes when fish are biting light. Coming up next at number 7 is Abu Garcia, specifically their massive range of entry to mid-tier rods like the Vengeance and Veritas series. Abu Garcia is under the massive Pure Fishing umbrella, which means their supply chain and manufacturing processes are highly consolidated. When you look at the engineering of the Veritas, for instance, they talk heavily about 30-ton graphite and special resin technologies. 30-ton carbon is a step up from the 24-ton baseline. It requires less material to achieve the same stiffness, resulting in a lighter blank. However, the engineering secret hidden in mass-market rods lies in the rolling process. Rod blanks are made by wrapping carbon cloth pre-impregnated with resin around a steel mandrel and baking it. In heavily consolidated, mass-produced rods, the pressure tape used during the baking process is often applied with less tension, and the baking temperatures are standardized rather than optimized for each specific taper. This results in microscopic voids within the resin matrix. To compensate for these potential weak points, factories leave the blank walls slightly thicker than necessary. So, while you are theoretically getting 30-ton carbon, the engineering execution leaves the rod feeling deader than a properly rolled blank of the exact same material. You are paying for the badge and the white paint job, while the underlying structure is compromised by mass production tolerances. At number 6, we have 13 Fishing. They exploded onto the scene with edgy marketing and unique component designs, but let's look closer at the science of those components. The guides and the reel seats are where rod manufacturers either invest your money or steal it. 13. Fishing often utilizes proprietary guide frames and ring inserts on their mid-tier rods, rather than paying the licensing premium for Fuji components. From a materials perspective, standard guide rings are made of aluminum oxide. Upgrades move into alkanite, silicon carbide, or torzite. When a brand uses custom stainless steel guides with zirconia inserts, you have to understand the manufacturing reality. Zirconia is hard, but the stamping and welding of the stainless steel frames on many of these proprietary guides lack the deep drawing and cold forging processes that companies like Fuji use. The result is that the frames are brittle, under the micro-stress of braided line ripping through them under heavy drag, or just the structural flex of the rod blank itself. These cheaper proprietary frames suffer from metal fatigue at the welding joints. The epoxy coating over the guide wraps begins to crack prematurely, because the guide foot is flexing more than the carbon blank beneath it. Verifiable in metallurgical stress tests, stainless steel frames that bypass the cold forging process exhibit a grain structure that is highly susceptible to corrosion and snapping. They sell you on the look and the aggressive styling, but the metallurgy of the components reveals a cost-cutting measure that directly impacts the lifespan of the tool. Here is where the numbers get uncomfortable. At number 5, we examine Okuma. Okuma occupies a very strange space in the industry because their high-end gear is legitimate, but their mid-range rods rely on a very specific engineering compromise. They offer incredible value, often utilizing 30-ton and sometimes even 40-ton carbon in rods that cost under $150. 40-ton carbon is high modulus, extremely crisp, and very light. But here's the structural catch that the industry doesn't want you to sit with. The higher the modulus of the carbon, the more brittle it becomes. It has zero tolerance for impact. To prevent these high modulus rods from shattering when you set the hook, manufacturers must use an advanced scrim. The scrim is the internal skeleton of the rod. Premium rods use carbon scrims. Budget rods use fiberglass scrims. Okuma, to keep the price down while advertising high modulus carbon, heavily relies on longitudinal fiberglass scrims. This creates a rod that is sensitive at the tip, but incredibly dead in the midsection where the fiberglass overlap is thickest. You feel the bite, but the energy transfer is lost before it reaches the reel seat. If you're finding this breakdown of material science helpful, take a second to hit subscribe, because we are only going deeper into the engineering from here. Moving to number 4, we have Dobyns rods. Dobyns is legendary for their tapers and balance. Gary Dobyns knows how to design a rod that feels weightless in the hand. But when we look at the engineering of the Fury and Sierra series, we see a masterclass in masking material deficiencies through balance. The Fury series does not use high modulus carbon. It uses a very standard, highly durable, resin-rich graphite blend. By all engineering metrics, a heavy resin 24-ton blank should feel like a broomstick. How do they make it feel so good? Counterweighting. They engineer the butt section and the grip with precise density materials, moving the balance point directly to the reel seat. From a physics standpoint, a heavier rod balanced perfectly at the fulcrum point feels lighter than a physically lighter rod that is tip-heavy. However, the total mass of the rod is still high. Over a 10-hour tournament day, you are still physically accelerating and decelerating that extra mass on every single cast. The kinetic energy required to stop the rod tip during a pitch or a flip is higher, which microscopically wears down your tendons. They engineered a brilliant ergonomic solution to hide a cheaper material choice. It is a fantastic fishing tool, but you are not paying for advanced aerospace composites. You are paying for proprietary taper geometry and brilliant ergonomic balancing. Fair warning right now. The next one is going to make you question every dollar you've spent on heritage brands. At number 3, we have the giant, St. Croix. St. Croix is a staple of American fishing, boasting their factory in Park Falls, Wisconsin. But let's run the math on their most popular, highest-selling lines: the Triumph, the Mojo Bass, and the Bass X. St. Croix markets their proprietary materials heavily, specifically SCII and Sigrudai carbon. This is classic industry obfuscation. SCII is simply their internal naming convention for mid-modulus carbon, roughly equivalent to standard 30-ton graphite. The engineering secret lies in their integrated polycurve tooling technology. While IPC is real engineering, the way it is applied to the lower-end series is highly deceptive. The Triumph and Mojo series are not rolled in Park Falls. They are rolled in their Fresnillo, Mexico facility. While there is nothing inherently wrong with Mexican manufacturing, the pricing model suggests a premium that the material science simply does not support. The blanks used in these rods are incredibly resin-heavy. When you look at the cross-section under a loupe, the ratio of epoxy matrix to carbon fiber is heavily skewed toward epoxy compared to their top-tier Legend series. Epoxy does not transmit vibration, carbon does. Furthermore, St. Croix has faced massive documented issues with their reel seats and guide epoxies in the Bass X line over recent years. From a materials perspective, they used a plastic compound in the proprietary reel seat that had a thermal expansion coefficient completely mismatched to the carbon blank beneath it. When exposed to hot summer sun and cold water, the plastic expanded and contracted at a different rate than the graphite, causing the reel seats to literally crack in half under the pressure of a torqued-down reel. Let's dig deeper into the actual chemistry of their resin systems. Premium rods use nanosilica resins, where microscopic silica particles are suspended in the epoxy to provide immense structural crush strength without adding physical weight. The mid-tier St. Croix lines utilize standard industrial epoxies. When these blanks are baked in the autoclave, the standard epoxy flows unevenly, creating microscopic pooling at the base of the rod. This pooling deadens the acoustic transmission of a jig hitting a rock. Every time your tungsten weight ticks the bottom, that sound wave has to travel up the line, through the guide ring, down the guide frame, into the epoxy wrap, and finally into the carbon blank. If that blank is choked with standard non-reinforced resin, the wave degrades before it reaches your fingertips. Documented in trade publications regarding composite manufacturing, the difference in vibration dampening between standard epoxy and nanoresin is near 40%. That means you are losing nearly half the sensory information underwater, all while paying upwards of $150 for the St. Croix sticker. The engineering disparity between a Park Falls Legend X and a Fresnillo Mojo Bass is a completely different universe of material science, yet they leverage their high-end engineering reputation to sell you distinctly average composites at a premium markup. Before we continue into the top 2 brands on the market, we have to address the elephant in the room regarding the material science of the blanks we've discussed so far. The institutional conflict of interest this video exists to expose is that rod companies are inherently incentivized to sell you the cheapest materials at the highest possible price point by burying the truth under proprietary acronyms. We've talked about tonnage, scrims, and resin, but the ultimate test of a rod's engineering is how it handles torsional torque. When you cast a rod, the blank doesn't just bend forward and backward, it twists. This torsional twist is the enemy of accuracy and distance. When a cheap unidirectional carbon blank bends, the circular cross-section literally squashes into an oval shape. As it goes oval, it loses its structural integrity and wants to twist off axis to release the kinetic energy. This means your lure flies offline, and you lose casting distance because energy is wasted in the lateral twist rather than pushing the bait forward. To combat this, the industry developed multi-axis wrapping. You will see brands marketing cross-wrap technology. But here is the critical engineering distinction that separates the mass-market rods from the elite tier we are about to reveal. Not all cross-wraps are structural. Many companies take their standard, cheap, unidirectional carbon blank and simply wrap a superficial layer of carbon tape around the outside, in an X pattern before baking it. This exterior tape does absolutely nothing for the structural integrity of the rod. It is purely cosmetic, designed to look like advanced engineering. It adds dead weight to the blank and provides zero torsional resistance. Consider the process of finding the rod's spine. Every tubular structure rolled around a mandrel has a natural spine. a line where the carbon overlaps and creates a slightly stiffer axis. In mass-produced rods, factories rarely take the time to locate this spine perfectly before attaching the guides. If the guides are glued out of alignment with the natural spine, the rod will actively fight itself during a cast. This creates immense microfractures in the epoxy over time and severely degrades casting accuracy. The next two brands on our list don't just use tape for aesthetics, and they employ robotic stress testing during the assembly phase to ensure that the guide train is perfectly dead center on the blank's primary flex axis.